Here's a third problem dealing with conversions. During a storm, a 2.6 meter deep section of the soil from a mountainside that measures 1.6 kilometers by 0.85 kilometers in area slides down into a basically squarish 0.42 kilometer by 0.42 kilometer valley. Assuming the wet soil ends up uniformly distributed and that it has a density of 1900 kilograms per cubic meter, what mass of wet soil covers a 9.0 square meter section of the valley floor? Ooh. Feel free to stop this video and try it on your own if you wish, but here's how we do this. We've got soil on a mountainside, and it measures 0.85 kilometers by about 1.6 kilometers, and it's 2.8 meters deep. Obviously, this is not to scale. That right there, 2.6 meters deep. And this slides down the mountain, and it slides into a valley that is basically a square. This is a 0.42 kilometer by 0.42 kilometer square. Now, we don't know how deep this is, right? These two volumes, though, have to be equal to each other. So by how many meters deep, we don't know that right off the top of our head. But we could figure this out, couldn't we? This is basically a rectangular solid. This is basically a rectangular solid. We don't know how deep this is. And we could do a bunch of conversions if we wanted, but look at this. If we go meters times kilometers, we're going to get some number. And look over here. If we go kilometers times something, do you see that if we equate these two, even without doing anything with the units, the unit that we're going to get in terms of our depth is going to be meters. You might say, oh, all the units have to be the same. Well, they have to be the same on both sides of the equation. Kilometers, meters. Over here, kilometers. Oh, this will be in meters. I went ahead and did that. 20 meters. Which, by the way, holy buckets, that's really a lot of soil there. 20 meters. Given one story is about 3 meters in a building. So this is about 7 stories of soil that is piled up in this valley. We want to know the mass of wet soil that covers a 9-meter section of the valley floor. So let's see, what do we have here? Density. If you want to put a D there, that's fine, but density is mass divided by volume. We're given the density, and therefore the mass is going to be the density times the volume. The density is 1900 kilograms per cubic meter. What's the volume that is covering that much? Well, the volume is the area times the depth. And so the area is 9.0 cubic meters. And what's the depth that's covering this? Oh, it's 20 meters. Boom, right there. This ought to be the mass. And dealing with significant figures, I think we should round our answer to 2. I calculated that the mass in scientific notation is about 3.4 times 10 to the 5th kilograms. So these problems are a little bit like making meatloaf. Of course, I don't eat meatloaf anymore because I have a plant-based diet. But when I did, I made meatloaf, and it was a real good one too. You just got to get your hands in there and mix it with your hands. You can't stir it with a spoon, so you got to kind of get in there and get ugly with it. Sometimes you have to do that with these conversions.